Hi.
Hello? Hello, guys.
Are we waiting for someone?
Yeah, I think so.
Yeah, that there's a few more folks from the CNCF storage tag that will be joining.
Yeah.
Hello?
Hey, guys.
Hey, Luis.
Hello? How are you doing?
Excellent.
Hello,
Hello.
Alex. I saw in the email, Luis. Hello?
Alex, good to see you again. I haven't seen you in forever.
Indeed.
Yeah.
So
And Sync
today
too.
we
Hey.
Hey.
today we have the StarRocks project presenting. Um, I don't know that we're waiting for many more people, so maybe we can start. What do you think, Zheng?
Okay. Yeah, so yeah, I'll try to share my screen. So let me first kind of introduce all of the folks from the StarRocks side. I am Sita. I am a StarRocks contributor, and a Kate. See here, she is the community manager for the project, and Tyler as well is from the StarRocks side. Okay. And Alex, I just got your email like 20 minutes ago about like more focus on the cloud native stuff. And but when I go through my slides, if you have any question, please let me just say it. We can do this kind of like conversationally because we have a relatively smaller group, right? um
Yeah,
okay,
I
that
mean,
makes sense.
so just to be clear, we don't change your presentation in any major way, but as we're going through, make sure to highlight the cloud native aspects to it. So, the way it's deployed in a cloud native manner, or scales in a cloud native manner, or recovers in a cloud native manner, to kind of sort of highlight um, how this fits within the CNCF ecosystem.
Yep, yep. Yeah, I'll definitely, I mean, I went through the slides and I hit a few. So I'll focus on, the cloud native aspect of the use case, the features and whatnot, right? Okay, so yeah, so it's gonna be fun. So yeah, so we're gonna talk a lot about OLAP today. So analytical, uh, database analytical queries, columnar store, and those kind of stuff, right? Let's get started. So StarRocks, technical overview. So for today's agenda, we're gonna first go through the state of OLAP and how software in OLAP is evolving, especially when cloud is taken into account. Cloud is changing a lot, in the OLAP architecture. I mean, for our architectural choices as well, and for users, what they're looking for. And then we're going to take a look at what is StarRocks and StarRocks kind of like past and future. So what we've been doing or what we had in the beginning and which direction we're trying to go next. And then we're going to take a look at some major features of StarRocks that solve actual user problems. Here I'll highlight, the ones that most related to cloud. Okay. So first, trend in OLAP databases. So there are a few things that we observe as we talk to user in the field, right? First is cloud native. We see a lot of users, not a lot, but like all of them, like trying to go to the cloud for their data warehousing workloads and for the data lake and for the OLAP workloads, right? So first thing they're really looking for is separation of compute and storage, right? So by separating your compute and storage, it's really important on the cloud, because like on the cloud, all of the resources are elastic, right? And you're only able to take advantage of those, of the elasticity, if you have stateless compute, right? So you can scale your cluster, with the demand, right, of your user, right? And also you can take advantage of cloud storage, cloud object storage, such as AWS S3, right? That's the kind of storage that is really scalable. Might be a little slow in terms of latency response time, but huge volume, right? Hundreds of gigabytes per second per bucket, and that's something that's extraordinary. And you can only take fully advantage of that, if you have a kind of like more cloud native architecture with shared data or storage and compute separated architecture. And then containers and Kubernetes, we see a lot of users adopting those technologies in their technology stack, whether it's on-prem still, they do a public cloud, like a private cloud because they want more security, or they're on the cloud, on the public cloud, either one, either way, it's really moving into that direction, right? And for OLAP itself, there are trends too. So people want faster query, right? So from minutes to hours, down to, sub-second or second level query, right? And with batch analytics, so process everything batch, the insight you get is not relatively as fresh. People are moving to streaming, moving to real-time analytics. And real-time, and they're looking for real-time analytics to get simpler, so everybody can use it, right? A lot of our users are asking for it. And then you have, immutable data versus mutable data, right? Data upsert is something that users are really asking for. And then it's proprietary storage format versus open and standardized storage format. And that is a conversation that's between the data warehouse and data lake and all of the data lake house conversation, right? And this evolution to data lake house, I'm going to explain in a bit. It's really a large chunk of it is a result of, everybody's moving to the cloud, right? So here is kind of like the difference between different kind of architectures with proprietary data warehouse and data lake house, right? So the main difference between the two architecture is the format that this data is stored, right? Either in like your file formats and your table formats, right? To store everything in Parquet files and in like open format, like iceberg tables, or you store everything in a proprietary format, which is enforced by the proprietary data warehouse itself, right? And this is really the result of, I think, kind of with cloud object storage being so powerful, right? So people are building data warehouses again on cloud infrastructures on like say AWS S3, right? And with the power of cloud object storage, now we actually have a chance to unify all of our workloads on a single source of truth data. So we store all of our data in one place in open formats, right? And we swap in and out of different compute engines and applications on top, right? And that is only doable, if your format, the format that the data is stored, is in a open and, more importantly, standardized format, right? And as opposed to, you store everything in proprietary, the amount of workload, I say Snowflake, right? The amount of workload you can run on that piece of data is limited by the proprietary data warehouse itself, right? But as opposed to, store everything in open format, now we actually have a chance to do that. And that paired up with a kind of open catalog service is what makes the data lakehouse architecture, right? Large part of it is because of the cloud. And now let's look at StarRocks community, right? We have 7,500 plus stars. Actually, no, I think just the other day it hit 8,000 on GitHub, and we have 350 plus contributors and almost 20,000 community members. We have record, right? And we have a bunch of like adopters of StarRocks, in their production in the industry, right? And so here is the StarRocks architecture overview. So we take a look at the two ways you can use StarRocks and the two problems that we're trying to solve, right? So first of all, StarRocks is an Apache 2.0 licensed Linux Foundation project, and it can be deployed in two ways, right? First, it can be your real-time data warehouse, where the data and the table format, the file format and the table format are in StarRocks enforced format, in StarRocks own format. So what you can do with this is that you can ingest data into StarRocks and get second level data freshness, right? And so your data would be like at most like 10-second old, right? So real-time analytics. And most importantly, with you can do that with mutable data. So you can perform data upserts and data deletes, right? With 10-second, like lower than 10-second data freshness. And the second way of using StarRocks is actually on the open data lake and data lakehouse architecture, right? And this is a new trend we're seeing. So basically what this is that you swap out the StarRocks storage engine. So we don't store data in a StarRocks format anymore, right? You take your own data lake or data lake house, bring that to StarRocks, and StarRocks can be the query layer on top of the lakehouse architecture, on top of your data lakehouse, and get great performance, right? You can get data warehouse like better than Snowflake performance on your data lake and data lake house, right? On your Delta Lake, Apache Iceberg, and Apache Hudi tables, right? And this is mainly the two ways you can deploy StarRocks for your different needs, right? Whether you want real time or whether you already have some kind of open storage, they're ready to go, right?
A
So
question.
here is,
Can I ask a
was
question
there?
previous?
Yes.
The left-hand side, so you would have like S3, those kind of cloud object
Yes.
storage beneath this your StarRocks files, right? That's
So
not showing
yeah,
here, but you will have
I
object
forgot to
storage
mention
there.
that. I was hoping somebody would ask. Thank you so much. And yes, so yeah, so as a data warehouse, it's only the file formats that's in StarRocks file formats, and StarRocks features a shared data architecture. So it means that no data is persisted in local disk. Everything is persisted in a remote storage, and for like 99% of our user cloud object storage, such as like AWS S3, right?
Okay,
That makes
thanks.
sense?
Yeah.
Thank you. Thank you for the question. And here let's take a look at the history of StarRocks. So StarRocks is a project that was forked from Apache Doris in 2020, and over the time we built almost like every feature we're gonna talk about today are built after the fork. So 90% of the original code base has been completely rewritten, right? And 2023, StarRocks was moved to Linux Foundation with a Apache 2.0 license, right? And we've have been, just building that from there. Okay, and here are some of the StarRocks use cases. Three. I'll go through them relatively faster. So first is real-time analytics, right? Which means that you get your data really fresh and you run really fast queries, right? So there's some key trends we see in real-time analytics. So first, data freshness. Users are asking for fresher data. They're asking for fresher insights. They want it to be under 10 seconds. And also they're looking for less pre-processing.
Hey, see
Yes.
there, I don't want to interrupt your flow, but you have a very technical, highly knowledgeable set of architects on this call as your audience. We
Okay.
probably don't need the architecture, we need the actual architecture, if you see what I mean. So if we could dive into the technical stack and that part of the presentation, that would be great.
Okay.
You, you,
So,
you don't need to sell StarRocks as a product to us, is what I'm trying to say.
oh, okay. Okay. Yes. So, we want to look straight into the technical features. Is that
And the architecture, yeah.
in the architecture? Okay. Um, okay, sure. Yeah, it's just here are just the use cases that we solve. So first for real time, for data lake house, and for user facing. And so basically a fresh data, really fast queries on open formats and with very high concurrency, right? And so here are some of the technical features that we've built over time, right? From the beginning of the StarRocks project. So after the fork, right? So the first things we built was for real-time analytics. So we built a vectorized execution engine from the from the bottom. It's completely native, right? Basically to vectorize every single compute operator to run OLAP queries faster, right? And also we built cost-based optimizer, which is very important for running fast join queries, right? And and the primary key table, that is designed to support second level data freshness with mutable data, right? And
Just
for
sorry,
StarRocks 2 point,
question.
yes.
You mentioned sorry to interrupt you, but you mentioned you forked from Apache. Have you talked about why you forked instead of being part of that community? What was the
We
need to fork and create this divergent project?
Yes. So at the time, Apache Tourist didn't really have the features that would support it, you know, um like what was it like didn't have the features that the users were asking for, basically. So that's why, we forked and we built, features on top of it. I'm not sure
That's
if
fine, but that question is, it's an open source project.
yes.
That's great that you have new features and good use cases. My question is, instead of forking, why not participate in that community and work with them to drive those new features?
I don't think I'm the best person to answer this. Can I
Okay,
go back and talk? Yeah, have one of our PMCs that
okay.
answer this question because I
Yeah,
wasn't
just
a part
that's
of the
fine. It's just one of those things that you, from my point of view, I don't know if others feels this way, but when we get a divergent project from a very big project that's already set up by another foundation, we have to be very clear to the reason why there was such a diversion, right? That this
yes.
isn't we're looking at this as another foundation and saying, why should we see this project where, you're trying to put it into this foundation? It's like I just want to know why was it separated from from Apache Doris in the first place, because
Mhm.
the way I see things is like it's either uh, a uh, a situation where you say, "Oh no, we want completely go in a different direction. We want to use Doris and other technologies." Great, that sounds like a great idea, right? But if it's really just Doris plus plus, then I want to really understand the difference. Does that make sense?
Yes, yes. So
Yeah.
yeah, it is, part of it was, like building a whole different thing. So like Apache Doris is a data warehouse, right? And but for our project, we didn't really, um release this, like right after we forked it because we haven't finished it. So we really see, Lakehouse as the future. Right.
Sorry to interrupt. I'm Kate. I'm also from the StarRocks team. I kind of want to say it's not the fork is not 100% a technical issue. That's the two teams or the funding teams have some I don't want to say disputes, but the Apache Stories was originally from Baidu, the company, and the team wants more control over the project. So so because of the direction, like we cannot come to like a consensus. So that's why the fork.
Okay. Thank you.
Yes. Okay. So yeah, so it's basically, like doing pure OLAP for real time as a data warehouse versus more cloud native architecture like a lakehouse architecture, right? And that's what our founder is saying at the fork and what they, wanted to build for the future of OLAP, right? And 1.0 was, after 1.x, so after fork, and then we started to build our data lake integration, right, for 2.x, for Apache Hive, for Iceberg, Apache Hudi, and for Delta Lake tables, right, to query the data there directly, as a lakehouse architecture, complete lakehouse architecture. And then for 3.0, it's one thing we started doing was shared data architecture, right? Although, like for a lakehouse, your data is stored in another system, right? Basically another data lake. But we still have, those real-time users, right? They want real-time analytics, so they want to do ingest. And also we have, materialized views, right? Which basically ETLs the data, transform the data into StarRocks own table format to change the schema, to do pre-processing, right, demoralization, and also transform that into StarRocks' own format for acceleration, right? And that thing needs storage and compute separation as well, right? And so from 3.0, the things we've been doing was basically to strengthen our integration with the lake and lakehouse architecture, and also more importantly, to build a complete shared data architecture, right? So we want to make sure that under any scenario, we're able to make our compute layer completely stateless. So that thing can scale. Basically, it can take advantage of the cloud, the powerful cloud, that elasticity and storage, right? And for 3.x, we're basically just gonna do that. So yeah, I'm not gonna waste time there. So going to the features, the technical features. So for performance, StarRocks embraces columnar store, right? Columnar file formats. So for all of the table formats that uses columnar stores, especially on the data lake, StarRocks support that, which are StarRocks own table formats, Apache Iceberg, Apache Hudi, Apache Hive, Delta Lake, and Python as emerging, right? And columnar store is really important for OLAP workload because you store everything in a columnar or orientation, and for OLAP queries, you scan everything by column, right? By storing by column, it's just way faster to do OLAP, and also you get way better compression ratio with columnar as well, right? And also, we completely rebuilt the execution engine. So for it to be vectorized, right? Vectorized engine basically says, hey, we want to process everything by batch in memory, and with our execution layer written in C++, right? We're able to take advantage of SIMD instruction sets. So basically, process every instruction we process, for every CPU instruction we process everything by batch, right? And that paired with the columnar storage, the files that's underneath, that's the main reason that we're able to get great performance, right? And also joins, right? This is one thing that StarRocks is really good at, and that is partly powered by our cost-based optimizer, right? That can do intelligent join reordering and select the best join mechanism, right? And do runtime filtering, right? We can filter data like when queries is still running, based on the actual statistic of the data, right? And we're able to run join at such a performance at scale, so a lot of users basically ditched their denormalization pipeline, right? So they're able to have their table normalized when doing their query, right? Especially for those real time and kind of like customer facing, user facing kind of scenario where the queries is not that complex and the data size is not crazy, right? So join performance at scale, this is something we're really good at. And this is our optimizer, our cost-based optimizer, right? And this is what powers our join performance, basically, right? And also we have a separated compute and storage architecture, a shared data architecture, right? As we talked about before, we have compute nodes, and they have cache, but they're stateless in terms of because they don't store any data, so they can query external S3 or object storage, external storage, where the data is persistent, so you can take advantage of the elasticity of the cloud, right? And also we have a complete caching system that's built in, both for a data warehouse and an open data lake, right? By doing a shared data architecture where you store everything remotely, the biggest cost of doing this is obviously the cost of actually fetching the data from your external storage, right? Whether the format is in our own format or is in an open standardized format, right? So especially for data lake house, right? That IO is expensive, and on the data lake or data lake house, the files can be unoptimized for query as well. So there can be a lot of small files scattered around, which is horrible for scanning, but the cache system can basically override that, right? And StarRocks has a hierarchical caching framework that based on memory and disk. And it also has, not only data cache where you cache the your data files, and also it has a metadata cache, right? So you don't have to talk to the metastore on the data lake, talk to the metastore as often, right? And this is something that makes our shared data architecture possible, right? This cloud native architecture possible, and
Hey,
this is
could you
what
give us a little
yes.
bit of a sort of breakdown as to typically how this would get deployed? You know, so where is it deployed? How would you deploy it? What is sort of your typical topology of sort of compute nodes to cache, etc.?
Okay, okay, so here's how it's deployed. I'll try to describe it. So StarRocks as a whole has like only two kinds of processes, FE and CN, and that's it. Two kinds of processes with no external dependencies. So all of the features I talked about, like regarding to cache, they're all built in. So there's nothing like you have to deploy yourself. So you just deploy StarRocks, the two processes, and connect StarRocks to a cloud object storage, just like AWS S3, and then you're ready to go to use StarRocks as a cloud native data warehouse. And for Open Data Lake, it's the same thing. You deploy StarRocks. You're gonna have two processes, FE and CN, right? And you deploy those, and connect and bring your own data lake, and connect StarRocks to that data lake with like literally like one command, and you can start querying immediately, and the cache is built in.
Now, I don't want to throw a kind of diverge this meeting too much, but I have to tell you that I like the way you're presenting. I like your slides, but the issue is, and I think this is going back to something Alex said from the beginning, is we are not seeing the internals of the system. Like, for example, when you say deploy this, just give you an example, and connect that, that sounds like magic to me. I want to know, this is the team here that
Okay.
wants to know the details of exactly how is it that you deploy, exactly how is it that you connect, exactly what happens to the IO, exactly how is it that you interface with the databases and things like that. This is too much of such a high level that we
Okay.
can't see how things are happening, right? We are the wrong team to present this to. Like, this is a great presentation, for example, for like the TOC, for example. For us, we want to
Okay.
see
Yeah, makes sense.
exactly how things happen. And
Okay.
so I don't mean to derail, but we haven't seen anything yet. How
Okay.
for example, I'll give you an example. You say there is a cache layer there, an execution engine. How does that work? How does the engine take IO or a request, talk to the cache, not talk to the cache, see a miss, go to the backend, all those things. What are the algorithms that it uses? Those are the type
Yeah.
of things that we're going to look for.
Yeah, get your point. I didn't prepare my slides that way. Yeah,
Yeah.
for that question, I could answer that question, but I think I got your point. So
Yeah.
do you think it's possible that we do another, I can go back and
I'll
do
leave that to
another.
Alex and Shing.
Yeah, absolutely. If you don't have the content today, but you know, as we're all here, it would be really good if you
Yes.
even if you could talk to it, sort of, delve a little bit deeper.
Yes. So for the cache, yeah.
But if you just saying if you're not the person either, then we'll need the right person too. Just I don't want you to put you in the spot, is what I'm trying to say.
Yeah, I heard your point.
If you feel that you're not confident to talk about that and you bring somebody else, that's fine too. No worries.
Okay.
But I'm just saying that
Um,
this content is not the content we are looking for.
okay. Okay, that makes sense. Yeah, do you still want me to answer that question, or yeah, I can.
No, I don't
Um,
need you to answer that specific question. I'm only
yeah,
saying
no, that's the
these
example.
are the questions that we're looking for. The answers we're looking
Okay, so maybe for another time, I would say, because this is about what I have. Yeah, so can we schedule a meeting presentation for another time if it's possible?
I think we could, but we still have some time left. Maybe you can still present whatever is that, because we could have more questions, right? Then you can
Yeah.
prepare for the follow-up meeting.
So look, there are two things we want to try and get to. One is a better understanding of the architecture and how StarRocks works, including how it gets deployed and how it would interact with something like Kubernetes and that sort of thing. And the second aspect would be, a better understanding of why you want to join the CNCF and sort of the benefits that you see from that, and how you fit into the cloud native ecosystem, specifically, because obviously, you're very clearly a data lake. The project is very clearly a data lake product, and it's not immediately obvious to me how it sort of fits into the cloud native ecosystem.
So I
Oh.
thought you have a Kubernetes operator. Can you, if you have a slide, maybe you can go with that one?
Yeah. Yeah, I should have probably like prepped a demo, honestly. Like for the operator.
Do you have an architecture diagram for the operator?
Not in this slide, I don't think. No.
Can you talk to it?
Excuse me?
Can you talk to the operator or how it
for. Then you
works?
talk about it, about the operator.
Oh, okay.
Yeah, how does it work?
It it's used to manage StarRocks cluster. I think you guys already know that, and yeah, we'll
We
definitely
don't know.
need a.
We do not know
Oh,
that,
okay.
right? This is the first time you're
Yeah.
presenting.
Okay, so
Explain
yeah,
to
so
me,
operator.
This is what
how
we
the
know. We
operator
know,
works.
yeah, we know operators. We know they read a CR, but
Yeah.
what they do with it is up to you. So we don't know that part, and that's what we're
Yeah.
looking
Okay.
for.
Yeah. Like the operator, StarRocks operator is used to to manage the life cycle of StarRocks clusters, deploying, scaling, auto scaling, upgrading, and monitoring. As well, you can plug it Prometheus and do monitoring, right? And this is I think this is the biggest competitor for any StarRocks vendor out there that's trying to do cloud. And it supports all kinds of StarRocks processes, so it can deploy front ends, back ends, and compute nodes. So StarRocks front ends are basically like the manager nodes of StarRocks. It does metadata management and query planning, and compute nodes are the shared data modes of the execution nodes, the worker nodes. So what they do is the actual query execution, and that's where the caching layer is, right? And with StarRocks, I mean, I hear you guys' point. I need to prepare architecture diagram to talk a little deeper about this.
Yeah, like for example, here's an example. It's like, how much intelligence is in the operator, or is it just deployment? For example, does the operator also see if when the Kubernetes cluster gets expanded, what does the operator do? Does it expand? Does the operator automatically elastically expand your cluster? Things like that.
Yes, it does.
Or is it in the control plane of your system? How does that control plane interact with this? These are the kind of questions that we are going after.
Okay.
And also, as you do that, I'd be interested on how you span clusters. So if you have capabilities for a hybrid cloud, it'd be good to understand that. Maybe you can answer that. Does StarRocks have to be in one and only one Kubernetes cluster? One instance of StarRocks?
Yes.
Okay.
Yeah, for one instance, yes.
Okay. And then you have the ability to define as many CNs as you want in that cluster. So is that a rules based as part of the operators setting some performance attributes, or
Yes. So so you can scale, use the the auto scaling capability that comes with Kubernetes. Right. You can set
what's making the decision to scale?
Based on the current status of your compute nodes, and you can configure that. Either
so when a compute node is getting highly utilized, you have a threshold that will invoke the starting of another shard or instance.
yeah, CN container. Yeah, CN container.
Okay.
And
So
yeah, because all of the data are stored elsewhere, and CN can talk to S3 directly. So the scaling up or scaling out process is fast. So this can automate do auto scale.
I'd like to continue with that question. Let's say you maxed out, or you have n numbers of CNs compared to the same number of nodes. So there's one per node now. How do you keep scaling out? Or do you go and say, the operator says, I cannot scale out anymore. I'm using the whole capacity of your cluster. Please increase the cluster size. Do you have limits?
Okay.
Do you have an interaction with here's the key part I'm really asking is, do you interact with the Kubernetes cluster to determine the limits or the integration that you can do with that system?
So here, if I'm understanding correctly, so if my my StarRocks cluster already hits the max limit of the whole Kubernetes cluster, right?
Yes.
So does the operator ask the Kubernetes cluster to buy more EC2s to?
That's exactly right. So is there an integration, in other words, between your world and the Kubernetes world?
Yes. That is a question actually I have to follow. I am not entirely sure. Yeah, that I'm not sure, but I understood the question. Yeah, I'll follow up with that question in the email thread.
Sure.
Yep. Any questions regarding this?
Can you maybe talk a little bit about what the project wants to achieve within the cloud native ecosystem, and why we're looking to join the CNCF?
Yes. So yeah, so from the beginning, we at least we believe that like everything regarding to OLAP will be moved to the cloud, and so does the architecture is gonna evolve more suitable for the cloud to survive, right? And this is the reason why we build shared data, all of the cloud shared data architecture, right? And also that's one of the reason, or the main reason why Lakehouse is out there, right? And why we are trying to be a component of the Lakehouse architecture. We want to work inside of the Lakehouse architecture, right? And so we think cloud native is the future, and that's why we want to join the CNCF projects, right? To add OLAP to the CNCF roster, and also to have better integration with future potential integrations with the projects that's within the CNCF storage projects, basically. Does that make sense?
A little bit. Like I'm still not very clear as to where this fits in the cloud native landscape. I'm going to be honest. I know it's database, but is it and it's an OLAP capability, but what?
So what is the concern? Can I ask?
I guess the question is more fundamental. It's more along the lines of, is this more than just an application that happens to run on Kubernetes? Is it inherently cloud native? Is it designed to scale and to deploy on demand? Is it designed to be declarative? Is it designed to be API driven? Like I'm trying to figure out, and maybe this is because we haven't sort of been able to dig into the underlying architecture. It's sort of hard to understand some of these things, but I'm not at the stage yet where I'm looking at this and thinking, okay, this is more than just an application that can be installed on Kubernetes. The CNCF isn't the home for every application that gets installed on Kubernetes, if you see what I mean.
Yeah. Yeah.
It needs to work in the ecosystem. It needs to integrate with other things. It needs to be, part of the environment. It needs to enable other things in the ecosystem. And I'm not seeing those connections, and probably I'm not seeing those connections because I haven't seen the underlying architecture yet, and I'm sort of struggling to make the connections in my head.
Yeah, one thing it could be, it's OLAP is kind of, I mean, in my point of view, is kind of different from a lot of other kind of applications, because OLAP itself is extremely heavy. So just OLAP by itself, uses a lot of compute and moves a lot of data around. And maybe like for the cloud, for cloud integration, OLAP is a little behind than other projects, to say, maybe. And we're definitely moving, with how do I say it? But I think you got my point, right?
So I'm wondering.
Sorry, I was just also following up on that list that you did, Alex. I think, how does the security model that you have now map into security features of Kubernetes would be interesting as you start thinking of how the back end is getting shared and all. So I think there's some security. I'd be interested to hear your view on security and multi-tenancy and things like that. But that could
security
come at a later time if you're not prepared to talk to it.
Yeah, at least I want to like understand like what we're looking for. So security in terms of like governance, compliance, and or like security in terms of like encryption or
Probably more in the governance and
governance. Okay.
yeah, GDPR and SOX and all that people may be using StarRocks and want to extend the security domain that they're using in their cluster, or make sure it's compatible or working, which may include encrypted data, which can affect, your compression and things like that.
Yes. Yeah. So for that's one by one. So first for governance, right? So for access control, StarRocks features a role-based access control, RBAC system. So you can define roles and assign that to a person. Um, right, has a full RBAC control. And for compliance, for GDPR, one thing really important for GDPR and it's challenging for OLAP is delete, right? Data delete. If the user offboards, you have to delete the data in a certain period of time. And Star was designed to handle that. Uh, it can do, the mutable data I was talking about was the ability to do updates and deletes. Even when the data is moving quite frequent, the ingestion is frequent, right? We can do deletes directly on columnar on our columnar storage. Uh, that satisfies GDPR. And for SOC, SOC 2 SOC 2 is more of like a practice for how do you manage um your entire like development process and things. And StarRocks itself is not some SOC 2 compliant, but Teradata, our cloud service is SOC 2 compliant and GDPR compliant. To answer your question.
Great.
Or you want to dig deeper into any specific topic just mentioned?
I think when we get down to how you're really using or not using the persistent volumes, or if you're going to use Cozy or other ways to map the object store, there's a mystery here in what's StarRock files and then what's an object store and then how the sharing goes. I guess I'd like to see that whole mapping. And then do you need like a service mesh to make that more secure? Would either there's a but
I think at a very high level, the sort of the issue we have is this has been more of a product presentation as opposed to an architecture discussion.
Yeah.
I mean, we definitely need to sort of get a better understanding of the architecture, if at all possible. If that's something, I don't know if you have that content somewhere else, and you could point us to it. That could be, something we could also look at. But I, we, I'm kind of similar, just following on from what Tom was saying. I it's not very useful to me to see, a CN talking to an object storage. I want to understand how the data is sharded, how it's laid out, what the topology of the CNs are, how they do their sharding
okay.
between
Yeah.
themselves, how do they balance the workloads, how do the queries work? Like those are the sort of things that we're trying to get to grips with.
Yeah,
the
well,
node failure application, as the node fails, how do things migrate? Do you have latency requirements? There's a whole bunch of things that are kind of curious.
Yeah,
when
that is a whole nother slide I can do. That is a whole nother presentation I can do. Not this one though. Yeah, I understand. So can we schedule one for sometime in the future, I can do this again, but with a complete different slides, if it's possible. I can explain the entire like create process, like from when it hits RFE, you know, how things are planned and how they get distributed to different like B or CN nodes and then failover, those kind of stuff.
I don't think I need, if you think of the water line at the persistent volume, what you do above it isn't really that interesting to me.
Oh,
From a
okay.
storage point, you could be Postgres, I don't care. But if you're doing something interesting with the file block and object, that's in the cloud native deployment. I think that would be something that would be interesting to talk about.
Yeah.
What you're
Yeah.
using, what you could be using, what isn't working as well, and maybe there's help we could do to. But so I don't. That's the storage side.
Yeah.
When it
Yeah.
finally
Yeah.
turns into
Got it.
requests somewhere, I think that's where it gets interesting to me.
Makes sense.
Alex nodding his head. So
Yeah.
So exactly how we interact with object storage and how we shard or how we distribute data, right? In different ways we can.
And how you interact with the environments, you know, with Kubernetes and
with Kubernetes
the deployment.
Yeah, I think you probably should focus on the operator, your Kubernetes operator, how that works, how that deploys the cluster and how that actually works.
Makes sense. Makes sense.
The data part.
And if you're using caching that's outside of the node in like a SSD tier and an elastic block SSD tier that you want to migrate if that FE fails, those are the kind of things we'd like to kind of hear about too. If the storage is reaching up, if persistent storage is reaching up into the caching layers above that green box on the slide right now.
How the cache algorithm works and
not the algorithm, but probably the control of it. How big, how small, when does it grow, when does it delete, when do you run out? Who knows that you have too little, too much? How do you tell the system to dynamically handle those changes? Those are the kind of things that get interesting in the intersection with the Kubernetes.
Yep. And how that interact with Kubernetes. Yes, we can do that, definitely.
That'd be great.
Yeah. Yeah, I think this is it. And sorry guys for bringing the wrong presentation. I did not know that. Sorry about
I'm also
that.
thinking maybe you could consider donate just the operator, but not the whole StarRocks project. That's just my 2 cents. It's just a thought.
Yeah. Yep. Yeah, that could be an option too. I'll go back and talk to our PMCs and see if we have a decision on that. I'll definitely propose that. Thank you. Any other question, or is it possible we schedule for another one? We can talk in the email threads, I suppose.
Yeah,
we can.
Okay. Let's do that. I think next meeting is booked, so it would be the 4th Wednesday in June. That's
okay. Makes sense. Yeah. Thank you, Nick.
Thanks everyone, and thank you for coming to present. Sorry it didn't go that smoothly, but we set ourselves up for success for the next one.
Thank you. Appreciate that. Thank you all. Thank you so much for the feedback. Thank you.
Bye-bye.
Thank you. Bye.
Bye.